the normal distribution and the normal calculator in StatCrunch. After watching this video, you will be able to use the normal calculator in StatCrunch to find the probability of an event using both standard and between settings, state the condition for an event being considered unusual, and determine whether a given event should be considered unusual. Introducing the normal calculator in StatCrunch. Go to statcrunch.com, log onto the site, click on Open StatCrunch, and then go to Stat Calculators Normal. Let's begin with this first example. Suppose test scores are normally distributed with a mean of 70 and a standard deviation of 12. Let's go to StatCrunch, open the normal calculator, and enter this data. We begin by going to the StatCrunch website and logging in, both of which I've already done. Next, we click on the orange button that says Open StatCrunch. In StatCrunch, we hover over Stat, Calculators, and then go down to Normal. Let's go ahead and enter our mean of 70 and our standard deviation of 12. And I'm just going to click on Compute to look at this graph. Now, notice that this scale down here, 40, 60, 80, 100, is something like you might see in an algebra class. But remember, in statistics, when we draw our normal curve, we usually draw a line in the middle or a tick in the middle to represent the mean, and then we count out from the mean in standard deviations. Can you find any button on the screen that will change the scale of the x-axis? Pause this video and see if you can figure it out. When I click on this button, which says 68, 95, 99.76, all of a sudden notice that this scale changes. Now 70, which is the mean, is in the middle, and when we add one standard deviation, which is 12, 70 plus 12 is 82. So now the scale looks like what we would normally see when we draw a normal curve. So to reiterate, the default setting is going to be a graph that looks like this, where you have a scale that, again, is appropriate for perhaps an algebra course, but really not appropriate for statistics. So as soon as we click on the 68, 95, 99.7 button, our x-axis changes, and now we have the mean in the middle of our graph, and the ticks indicate integer or whole numbers of standard deviations away from the mean. Again, this graph is more appropriate for statistics and should always be used in this course. So try to always remember, especially if you are doing a screenshot of this picture to put into a project or report or assignment, to click on this box first. Example 1. We're going to use the same information. We're going to suppose test scores are normally distributed with a mean of 70 and a standard deviation of 12. This time we're going to compute the probability that a randomly selected person scores below a 60. So in StatCrunch, we already have our mean and our standard deviation. This time we actually are going to fill out an x value. And the x value that we're curious about is a score below 60. So make sure the less than or equal to sign is selected. Type in 60 and hit compute. So we have this screen here. So let's interpret our results. This says that the probability of a person scoring less than 60 is about 0.20 or 20%, which is the value we have right here. So what this means is that if I cut this probability distribution at x equals 60, that about 20% of the area under the curve, or 20% of the population, lies to the left of this value, and the other part, which is in this case 80%, lies on the other side of that line. Now we're going to use this result to answer the question, should a score of 60 or less be considered unusual? Remember, we generally regard unusual events as having a probability of 0.05 or less. This probability is about 20%, which is more than 5%, so it would not be considered unusual. Example 2. Compute the probability that a randomly selected person scores above a 90. In our calculator, we need to change two things. First, if we're doing above a 90, we need to change our inequality symbol. Then, we need to clear this value and put 90 in instead. According to these results, the probability that a person scores 90 or higher is about 0.0478 or about 4.78%. This means that if I cut this probability distribution at x equals 90, that about 4.78% lies to the right of that line, and the remainder, which is about 95.22%, lies to the left. Should a score of 90 or above be considered unusual? Remember, we generally regard unusual events as having a probability of 0.05 or less. The probability of this event, 0.0478, is just under 5%, so it would be considered unusual. Example 3. Suppose test scores are normally distributed with a mean of 70 and a standard deviation of 12. Compute the probability that a selected person scores between 65 and 80. Notice in our calculator, we don't have room for two x values. So what we need to do is come up here and click on between, and now we are allowed to sandwich our x between two x values. Our mean and our standard deviation are already typed in for us, so we can change these x values to 65 and 80 and then hit compute. So let's look at these results. The probability that a person scores between a 65 and an 80 is about, as you can see here, 0.46 or 46%. What does this mean? This means that if I cut the normal distribution twice, once at x equals 65 and another time at x equals 80, the area in between these two values is about 46% of the population. Part 2. If 500 people took the test, about how many would you expect to score between 65 and 80? To answer this, we simply multiply the probability by the number of people who took the test. Remember, the probability is about 0.46, and 500 people took the test. Multiplying these numbers, we find that about 230 people would be expected to score between 65 and 80. Example 4. Suppose test scores are normally distributed with a mean of 70 and a standard deviation of 12. Compute the probability of a score less than 65 or more than 80. Notice I've chosen to use the same graph because the cutoff points are still 65 and 80. However, the areas of interest are no longer the red shaded region in the middle, but this unshaded region on the left, less than 65, as well as the unshaded region on the right that is larger than 80. Unfortunately, there's no way to make StatCrunch shade these two disparate areas. So what we have to do is what we've done in the past, which is to use the complement rule to find the unshaded area. So we have 1 minus 0.4592, which is about 0.5408. Notice when I did this calculation, I used a higher precision just to avoid some rounding errors. So the probability of a score that is less than 65 over here, or more than 80 over here, is about 0.54 or 54%. Part 2. If 1,000 people took the test, about how many would you expect to score less than 65 or more than 80? To answer this, we simply multiply the probability by the number of people who took the test. Remember, the area of the unshaded region is about 0.54. Multiplying this by 1,000, we find that about 540 people would be expected to score either less than 65 or more than 80. Having watched this video, you should now be able to use the normal calculator in StatCrunch to find the probability of an event using both standard and between settings. State the condition for an event being considered unusual, and determine whether a given event should be considered unusual.